I graded those the day you took them, and I sent you your grades right away. And then I forgot, and I left these things tucked in the back of my book. So I graded them right away, and I didn't hand them back to you. Sorry about that. So anyway, I know you knew about the grade. Well, most of you. A couple people had to make it up, and then. Well, and secondly, hope my voice will last. I'm not doing too well today. But anyway, does anyone have questions on? Let's see. The section we had last time was 3.6, right? Right, truth table and validity of arguments.
Could you do number 25?
Sure. Number 25, let's see if I got it. Okay, here's 25. Yeah, and I never did one with a trigger like this. But anyway, the list on the left is what they gave you. If P, then Q. If Q, then R. If not S, then not R. P. Just plain P. Well, this was a pretty easy one to see. Well, first of all, these two chain together, don't they? And this one, if we just do a contrapositive, would be if R then S, and nicely chains. Okay. Now, can you draw a conclusion from those three? Yeah, if P, then S. Okay, so that makes sense. So if you've got P, then I'm going to give you S. That's kind of what it amounts to. And guess what? You've got P. Therefore, I'm going to reward you with S. So we sometimes call this a trigger. So even though it wasn't in the chain of events, it's kind of like the trigger that, started the dominoes falling? Yeah, I didn't show you about that. Yeah.
Okay, so the rule is with the negation one.
Right.
You can just flip it around.
If you do two things, you flip it and you negate them both.
Okay.
Because that's called a contrapositive.
Okay.
Right. And contrapositives are completely equivalent to the original. And that's why it's legal for me to do that.
Okay.
Yeah. Follow up?
Could you do number 27, which is like...
Anybody on this one yet? 27? Okay. Well, here's what I did. Well, nothing changed now. I took the contrapositive of that. If not Q, then P. And then, okay, where did I get this one from? This is that hint. That hint said if you ever have a not something ORed with something, it's if that, then the second. Now look at chain. Cool. And therefore, on those two, we could say if not Q, then R. All right. Now, this is a little tricky. I still don't have any R's. But if I take the contrapositive of my conclusion, what's the contrapositive of this? If not R, then Q. Now, take your trigger. You've got not R. Therefore, you get Q. This one was tricky. It had a couple twists and turns to it. So, I had to play around with these to get them so they linked up. And then when I got them linked up, I had to actually take the contrapositive of my conclusion before I could see anything of value. And now, finally, this makes some difference. So, final conclusion, Q. It's kind of like these if-thens are like, if you've got not R, then I'm going to award you with Q. And you've got not R, so I should award you with Q. Kind of corny, but that's how it works. Is there another one you'd like to look at? cold cough stuff. But I'm thankful I haven't been struck with the flu yet. Sounds like that's been pretty wicked for the students. Lots of bad news. Well then, we're going to move to our section 3.7 lesson, which is called Switching Networks. 3.7, Switching Networks. And here's where logic takes a really interesting turn. If you do, by the way, I'm not going to do it right now, but if you take your favorite internet search engine and type in logic and just do search, you will find mostly computer parts that will come up. And you're probably thinking, what's going on here? Actually, that kind of a board right there, that's called a logic board. And you might think, oh, no wonder it's messed up. It thinks that's logic. Actually, that kind of a chip contains the exact things I've been teaching you in this chapter. It's not really very bright because it only can understand on and off. In this case, on stands for true and off stands for false. But since true-false is just a two-way deal, it's only two settings, it kind of fits with these TF truth tables we've been doing. So, would you believe I'm actually going to teach you a little bit of wiring today? Not very practically. I don't have parts I'm going to hand to you, but I'm going to show you some really simple circuits, and I think you're going to catch on right away what's going on. So, here's the first one. I'm going to teach you. You all know what this is. It's AND. And what's the rule? Yeah, only true when both are true. In terms of electricity, that would say only on when both are on. It's the same deal. So here's the picture I'm going to show you for AND. That is an AND switch. You notice altogether there are two switches in here. There's a switch P and a switch Q, just like statements P and Q. And that's real corny, but that's a battery on the left and it's a light bulb on the right. And the point is, what would it take to turn the light bulb on? Assuming we're connected on the left. Isn't it obvious that you got to have both switches closed for the power to get over to the light bulb? Just by looking at it? If I close switch P and turn that on, the power still won't get there, right? But if I close them both, isn't that exactly how AND works? Only true when both are true, only on when both are on. So you are looking at an AND switch. And it's pretty easy to identify. Okay? Here's my little description. In this sketch, the power from the battery at the left will only get through to the light bulb at the right when both switch P and switch Q are closed, or we would call it on. So this electrical circuit is the perfect picture of how AND works. Okay, let me talk a little bit too about the circuit on the bottom. This is called a series circuit. I've got a bunch of twinkling lights because I'm reminded of the old sets of Christmas tree bulbs. Okay? Now if you get a really cheap set, they may not even make these anymore, but if you get a really cheap set, what happens when one bulb goes out? The whole set goes out? The more expensive sets, that one bulb out doesn't cause everything to go off. But I'm sure you've dealt with those, haven't you? I can't tell you how many hours I've spent under a tree, one bulb at a time. You know, replacing one bulb at a time to try to find the bad guy. Yeah. Well, that's basically an AND switch, which says the only way for all the bulbs to light up is if they're all good. If I've got a bad bulb, the circuit won't go through, and all the lights in that set will go off. That's called a series circuit. And guess what? It's cheaper because, well, it's a little bit less wire. Okay, now, the second kind of wiring I'm going to show you is this good old guy. You all recognize him. That's the what? Inclusive OR. And what was the logic rule for this? Only false and both are false? Okay, so in electricity, only off when both are off, maybe? Let's see. Here is an OR switch. Okay, you notice we have a battery and a light bulb again. And again, I have two switches. What do you think would happen if I only turned on switch P? Would the power get through? Like if I close this right now, then couldn't the power go like this? And it would get through. Yeah. What would happen if I only closed the Q switch? Wouldn't it get through again? And what would happen if I closed both of them? That would work too. This is a perfect picture of, how does this work? Well, the only time it's false is when both are false. The only time this light bulb will stay off is when both are off, like it is right now. If I close either one or both, we will have light. Does that make sense for looking at the picture? Usually when I show this, everybody goes, oh yeah, I can just see it. You can see it, you can just trace the power going through. So, just think it through. An AND switch, they were side by side, and an OR switch, they're just kind of stacked like this. Actually, that's all you have to remember. AND, OR. There we go with arm signals again. But you get the idea. And they're kind of in a row, and when you have the inclusive OR, they're going to be in a stack. Okay. Okay, now comes the good news. These are the nicer Christmas lights that use this switch, the OR switch, because now when one bulb goes out, it doesn't turn off all the sets. Every light that's good will wait. And I'm hopeful that every set of Christmas lights that we get in the future will be of this type, because they're a lot easier to work with. When one bulb is out, who cares? They're usually what now? Most sets are 100, and you can't tell much difference between 99 and 100. And I don't know, maybe it shows I'm lazy. But anyway, before, when one light went out, all 100 went out. And then, of course, you couldn't live with that. You'd have it, especially if you put them on around the tree, that would be like dark on the bottom. And of course, nobody could stand that. So anyway, that's called a parallel circuit. And they're a little bit more expensive because they have an extra wire that kind of travels throughout. That's this doubling up, this stacking. It's almost like two parallel, you see why they call it parallel? Two parallel wires kind of run throughout the whole string of lights. A little bit more wiring, a few more parts. Makes sense. They're going to be a little bit more expensive. So what we're going to do now is we're going to translate logic statements into wiring diagrams. And we're going to translate wiring diagrams back into logic. So, we could actually make up an argument of logical statements, and we could actually wire it. And this is why, by the way, that computers work so well, because they're into this true-false, on-off. Computers make a beautiful link-up with the concept of logic. Well, let's see if this makes any sense. First of all, you aren't going to have to draw light bulbs, and you are not going to have to draw batteries. Okay. So what we do, make believe there's a battery on the left and a light bulb on the right if you want. So just remember, and OR. And those are the only two I'm going to teach you. Are there more? Yeah. There's another wiring diagram for this. There's another wiring diagram for this. But I'm only going to be teaching you the two you already have, and OR.
So how would we set this up? You notice we have parentheses, Q and R. Well, we know an and looks like this. So I gotta have Q and R set up to be horizontal from each other. You see how I have Q and R next to each other? But that whole part, Q and R, has to be stacked with P. Why? Because of this guy. So do you see how I took Q and R, I made them side by side, and yet I was still able to make a little stack with P. There it is. That's the wiring diagram for that logic statement. Yes.
Oh, I just have like a general realization. So it's a wire, the electricity either has to go through P or Q and R.
You got it. Exactly. So like, if the battery was here, light bulb was here, if switch P closed, that would work.
Yeah.
On the other side, let's say P is open, but these are both closed. Yeah, then the power would go through on the bottom.
Okay.
And what would happen if all the switches are closed? Well, the power will go through great then. So that's going to work too. Yeah, that was a good way to say it. Good job. Yeah, I shouldn't have them all done already. Sorry about that. I don't know if I have the energy here, but let me just start this over. I'll just show you how we create this, okay? You can see that here we have two sets of parentheses. You know by now that parentheses are things you have to do first, correct? So how do I draw a diagram for P or Q? Isn't that a little stack? What I would call a stack. So we got something like this. And I usually draw them just like this. Okay? I meant R. Thank you. Wow, I switched. Yep, should be an R. Okay, and then over here, Q or S, isn't that a stack again? Same deal. And then aren't these two stacks ANDed? So aren't the two stacks side by side? So all I got to do is just kind of connect these. And then make sure you have a beginning and an end. Wiring diagram complete. Now I got to tell you, the book does it just slightly differently. Okay, I want to show you one in the book. I don't know why, but they put an A for the beginning and a B for the end. Notice I have not done that. You don't have to. Okay, so they will put a letter A here and a letter B over here. That's fine. They're not needed. Okay, should we try another one? Does that one make sense? So do you see? So parentheses are still first. Okay. Something from the past. Yeah, here's what you do with a not. Let me erase these and we'll do them over. When you have a not, like here we have a not R. The way we handle it is we just write it as R with an apostrophe, kind of like the old complement days. Do you remember? A apostrophe meant a complement. So here's what we do. We got a set of parentheses here. So we got to do that first. P or Q. What is that, a stack or a side by side? That's a stack. And then that is ANDed with, that means side by side with, not R. And that one's done. Now, I really have a complex one here, but that's okay. We might as well just jump in and do a more complicated one. Look at all of this. Holy cow. We got all kinds of twists and turns here. Well, we got to look for what? Our innermost parentheses? Where are they? Right here and right here. And they're both ORs. So those are stacks again. So I'm going to have a P ORed with a not Q.
Okay, and over here, I'm going to have a not P ORed with a Q. And then, okay, now, I've got to, okay, I'm going to have to move this because this, along with this, along with Q, and now I'm in the square bracket. The square brackets is my next level. What does the square brackets have? This is ORed with Q, which is ORed with this. That means all three of those have to be in another stack. So, here's how I'm going to draw it. So that's ORed with Q. And then that's ORed with that thing. Getting a little mixed up here. Okay, you see how I have those all ORed now? Now that whole thing is ANDed with Q. Well, that means it's side by side with Q. So then I'll get rid of this. Then I would just throw on a side by side with Q. Let me get rid of this because I moved it. And I see I erased a little too much. It's supposed to be a Q here. That one's a little bit harder to see. We'll just go over it again. I've got, as you know, I had a stack for this, P, not Q, and here I had a little stack, not P, Q. And then these told me that all three of these things have to be stacked again. So I had to take this little stack, and stack it with Q, and with this little stack. Now, it would be okay, it's okay to bring these sides all the way down, straight down, and have one big happy stepladder, I guess, kind of thing. But what I like about this is it shows a little bit better what's happening. So if you just branch out a little bit like I did, it shows kind of the order better. I maybe shouldn't have jumped to that one, but it's number 6. Okay, here's another one. Let's erase and start over. So, in parentheses, we have a P or Q. Well, that's a stack. So we can put that in. And then, both, the rest of the problem is all AND, isn't it? So from here on in, it's all side by side. So I got a Q, side by side with a Q, side by side with my stack. Put a beginning and an ending on it. All set. Wiring diagram. Again, let me erase. Let's try this one. Really doing this together. Okay. Innermost parentheses are underlined. I got 3 guys. The first guy is an AND. Well, that's a side by side, isn't it? P and Q, side by side. But that's going to be stacked with, so I know we're going to be doing this, it's going to be stacked with another side by side, another AND, not P and not Q. And that, in turn, is going to be stacked again with Q. Because, again, we have an OR. Okay, so now I got the big bracket done. And what's the last step? Take all of that stuff on the left and AND it with P. So put it side by side with P. And we got it. Again, I'm skipping. The book puts in, you don't have to do this, the book puts in an A for the beginning and a B for the end. we just don't need that. And you don't have to draw a battery and a light bulb. But the reason I wanted to put that in there is and demonstrate to you that this really is like this really will work in wiring. I've always kind of dreamt someday to have enough tools where we could actually build an AND circuit and an OR circuit, and then I could show you that it really works. And when both switches are down, that'll cause this light bulb to go on, you know, that kind of thing. I haven't done it yet, but okay. Yeah, well, let's do one in reverse. This time, let's start with a circuit, and let's change it into logic. Okay, can you read it backwards? Here we go. Excuse me. So, would you agree that I have a big old stack here with 3 things on it? What does that tell me? Those 3 things are ORed. So I know I've got, you know, like part 1 or part 2 or part 3 for this part. What are the 3 parts? What's on the top rung of the OR? P and Q side by side. So isn't that a P and Q? So that's the top rung. The middle rung is not P and not Q. Why is it and? Because they're side by side. And what's on the bottom rung? Just a Q. So do you see that I have my big old stack done now? And now what am I supposed to do with that? I'm supposed to take all of that, and because it's side by side with P, that's telling me and it with P. So you can probably tell, we're going to want you to go both ways. Start with a logic statement, draw a quick wiring diagram, start with a wiring diagram, come up with the logic. Now, a little bit of a challenge. What in the world are we going to do with translating this into wiring, if P then Q? Well, there's a hint that we had, or I think we've had it. Yeah, we had it in the if-then lesson, whenever that was. I'm going to have to go find it for you. The conditional lesson. That would have been 3.3. Yeah, it's in number 40. So you're going to want to copy this down in your notes. I will put it up here too. In number 40, you will see this. It says, if P then Q is equivalent to, not P or Q. Okay, so these are equivalent. Well, I only taught you how to do these guys and these guys. So you sure can't draw a wiring diagram for this. So what could we, sorry, what could we substitute for this? Not P or Q, right? So I'm going to replace that because we're told it's totally equivalent. Okay. All right, the rest of it's fine, I think. Ah, we got to do another thing. What in the world? Let me erase the second part. Do you remember a law that lets you do this? How do you negate an AND or an OR statement? Isn't that De Morgan? Remember De Morgan's laws? De Morgan says, yeah, negate them both. That'll make that one negative and that one positive. And then what do you have to do? Yeah, exactly. So, is everybody with me? So this one took a hint. This hint down here, which is very important. We should probably box it because it's worth putting in your notes. You probably will make use of that in your assignment. And then, on top of that, we had to use De Morgan's law. Okay, now we should be able to make a diagram. So, in parentheses first, we have some stacks, don't we? not P is stacked with Q. And over here, not R is stacked with P. And then what's to connect them? An AND. So they're side by side. Just stick a beginning and an end on it. Wiring diagram complete. Okay, I think we've probably done enough of those now. That's the challenge. I think you'll find it's not that terribly complicated. Okay, I gotta look it up. Assignment. So you're all remembering the calendar that for next time, you can bring your notes. You don't have to bring your books because next time it's going to be a presentation and I want you to take some notes. And then when you come back from break, the first thing we're going to do is have questions on this assignment and what I call review 1. And then on Wednesday of that week, review 2. So we will have a week to get ready. And then Friday of that first week back would be our test on chapter 3. Okay. Now do you see why I have the picture of the computer board on this site? Yeah, now it's kind of coming together. And the assignment is 1 through 19, the odds. 1 to 19, the odds. Why don't you just get a couple of them done, get warmed up a little bit. I'll let you go early. Oh yeah, and those quizzes are punched, so you could stick them in your 3-ring binders. Did anybody have any questions on the quiz? You probably don't because you got it all in your notes, right? The correct way to do the quizzes. But I mean, if you have any questions, let me know. I'll go through them.